In this lesson, we're going to find out how to evaluate a polynomial function. We have done this before with linear functions, and we've substituted values in, so we're going to do the same thing here. It says find f of 2. So what they're asking me to do here is when they say find f of 2, they're asking me to replace, see how this y was replaced with a 2? So I'm really going to replace each of these y's with a 2. So I'm trying to find that specific ordered pair for that equation. So I'd write f of 2 equals, and then wherever there's a y, I'm going to replace that with a 2. So as I go through and simplify this, the notation in the beginning, the function of 2, is actually very necessary, so you don't want to drop that off in your answer. I'm going to simplify this using my order of operations, so I did exponents first. And as I keep going, I'd have 12 minus 6 plus 1. 12 minus 6 is 6, 6 plus 1 is 7. So I find that f of 2 equals 7. So what that's telling me is when I have a value for my independent variable, my y in this case, of 2, the other value is 7. So the ordered pair 2, 7 would be a pair that would be on this graph. And you could actually graph this parabola if you wanted to on your calculator and see that 2, 7 would be part of your table. We're finding that value there. Another example of that is right here. So I'm going to let you guys pause the video, please, and try this problem, and then you can come back and see how you did. So f of negative 3, we're going to substitute negative 3 in for y. And again, I'm going to follow my order of operations. So I have 3 times 9 plus 9 plus 1, which gives me 27 plus 10. So I find that f of negative 3 equals 37. If you want to do what I did in my work and leave this off, that would be okay as long as it's in your answer. So my f of negative 3 equals 37. Last one, I'm going to let you guys try again, make sure you've got it. Here we're substituting negative 5. So as I use my order of operations, I have 3 times 25 plus 15 plus 1. So we end up with 75 plus 16. So f of negative 5 equals 91. And this is the one we've done before, is where we had actual number values in there. So hopefully those don't seem too new to you and they kind of make sense. The new ones are these next ones, where we're actually replacing one variable with another. And the reason you would do that is if you are substituting, you have lots of different variables as part of your equation. Even if you're doing a real-world problem, even with something as simple as figuring out your paycheck, you have to factor in how much retirement comes out, how much taxes you get charged, how much comes out for maybe your flex account for your health insurance, things like that your parents probably are dealing with all the time. And this would be a formula that the computer would use to compute this. And so we're going to replace this a squared. It says find p of a squared if p of x equals, and they gave us this cubic equation. So wherever there's an x in this equation, I'm going to replace that with a squared. Nothing else is going to change though. So I'd say p of a squared equals, and I have x cubed, so I'm going to write a squared cubed plus 4, and then where the x is, I'm going to write a squared again, and then this isn't going to go away, so that's going to be there as a squared, minus 5 times a squared. Hopefully you can tell that my answer here is going to be in terms of a variable. So I'm not going to get a nice neat answer like 7 or negative 10. I'm going to have a whole nother equation here, which makes it seem like you're wondering maybe why you're doing this, but it's actually simplifying steps if you were to apply this to an actual word problem. So now as I go through, I'm going to use my rules for exponents. Remember, when I have a power, a squared cubed, I multiply those. So I'd get a to the 6th plus, this 4 is not being squared because it's outside the parentheses, so that's going to stay a 4. And then when I take a squared to the second power, I multiply those and get a to the 4th. And then here I'm just multiplying a constant times a variable, so I'd have minus 5a squared. So when you put it all together, you get p of a squared equals a to the 6th plus 4a to the 4th minus 5a squared. This is an example of an equation that has a degree of 6, and its leading coefficient is 1. The next one, this one is our kind of complicated one that you're going to have a few of these in your homework, and you have to really just take your time on this and not try to do too much at once. And so when I have q of a plus 1, I have that, and then I'm subtracting 2 times q of a. So let's write that out, how that would look. So q of a plus 1 minus 2, oops, no parenthesis yet, 2q of a. So first, I'm going to take my equation, and wherever there's an x, I will replace it with a plus 1. So I would have a plus 1 squared plus 3 times a plus 1 plus 4. So that is this first part of the equation. Now, the minus 2 times I would write as this, minus 2, and then I'm going to have a parenthesis here, because I know I have to take that whole thing times a negative 2. And then my q of a, I'm going to replace all the x's in that part with an a, which really isn't going to do anything except change the variable. So I would, instead of having x squared, I'd have a squared plus 3 times a instead of x, and then plus 4. So take a look at that for a second and make sure you see where I got all of my variables, where I substitute everything, because if I don't do this part right, everything else I do in my work is going to be wrong. So you want to really make sure you didn't have a copying error, you substitute everything exactly as you were supposed to, and then we'll use our order of operations to actually simplify this problem. So as I come down, if you remember, our biggest mistake people make in advanced algebra is that they just think they can square both of these, but you have to remember that when you take a plus 1 squared, you're actually taking a plus 1 times a plus 1. So I'm going to have to do that in a minute. I'm going to go ahead and distribute my 3, so I'd have plus 3a plus 1, bring down the plus 4. Okay, so let's just pause for a second. Make sure you can see why we're getting everything we're getting there. And then I would distribute a negative 2 to all three parts. So negative 2a squared minus 6a minus 8. I would probably, because I'm kind of lazy and don't want to show all this work, is I would maybe FOIL this right above. So I have a squared plus 1a plus 1a plus 1. So I don't have to write a whole nother step for that. So as I come down here, q of a plus 1 minus 2 times q of a equals, and I'm going to combine like terms right now. I can see that my highest degree is a squared, a 2. So I'm looking at my squareds, and that's all I have, right? So I'm going to add those. A squared plus a negative 2a squared would be negative a squared. Then I'd go, those are done, I'd go to my a's. I have 1a plus 1a, that's 2a, right? Plus 3a, so 5a, minus 6a. 5a minus 6a would be negative a. So I took care of all my a's. Last, I'd look at my constants. 1 plus 1 is 2, plus 4 is 6, 6 minus 8. Oh, you know what? You guys probably thought I made a mistake, didn't you? Look at this. I just found my mistake. Almost got yourself a pack of gum. Right here, look at, see my mistake right here? You guys probably were thinking this should be a 3. Hopefully you caught that. When I distributed 3 times 1, I should have written a 3 here. So now, hopefully everyone sees that. It's coming right here where I wrote 3 times a is 3a. I went right there. 3 times 1 should have been a 3. So let's replace this number with a 3 and try this again. So I now have 1 plus 3, which is 4. 4 plus 4 is 8, and then 8 minus 8 is 0. And I'm not going to write a plus 0 on the end, because that's not necessary. So this is actually my answer. And if you look at what we started with, this simplified quite a bit, didn't it? And again, I'm leaving it in terms of a variable. You're going to have quite a few of these on your homework tonight, and you just have to take your time and go through them very slowly, and some of them will be a little bit confusing, so just try them, and if they're hard for you, then ask for help and I'll come help you with them. But this is kind of something you have to try on your own before you really get the hang of it.